First off, thank you guys so much for being here. Today we're talking about the ASIC frontier. Everything lives and dies by the chip, right? It's what's on the press release anytime something comes out. We have assembled with us a few particularly brilliant experts in the space with a diversity of experiences when it comes to ASICs. And I'd love to get into a conversation so that we can help individuals understand, nobody understands ASICs, right? So we can understand what the heck is going on. What is this industry? What are we doing? What are the problems we're running into, and where are we going? But before we do that, I'd love to kind of move across and introduce yourselves and let us know who's in the room.
All right, I'm Bob Burnett. I wear a lot of hats, but I'm the CEO of Barefoot Mining, which is a mining company. We focus on small and medium-sized mining operations, especially off-grid. I'm also on the board of directors at Ocean. I'm also on the board of advisors of a company called Block Spaces, where we're working on a forward contract derivative for block space. And I am part of the M5ers team, where we are developing a new Bitcoin mining ASIC.
My name's Christopher Kroll. I'm with Canaan Inc. We're a NASDAQ-listed company in New York City. We've been around since 2013, so a long time Bitcoin miner, the first Bitcoin ASIC miner, you could say. My name's Christopher Kroll. I'm head of business. We are excited about this next cycle coming up because the opportunities are here again. We move in 4-year cycles, right, guys? So it's time to do it again. So everyone pick up miners while they're cheap, right?
Hey, everybody. My name is Zubair Ahmad. I'm a product manager at Proto, which is part of Block. And we are relatively new to the mining space. I'm relatively new to the mining space. We do have a product called BitKey released. I myself have about 20 years of semiconductor and hardware experience at large companies that make gaming processors and all your mobile phone chips. So I've been in this industry for a while, but new to mining and such a welcoming community. I'm happy to be here.
Amazing. So let's open it up to open-ended question. We obviously hash. We hash SHA-256D. We do it on an ASIC. It's the chip, not the machine. Help us understand what problem we're solving for. Is this something that you can do in your basement? Is this something I need $1 billion to do? What are we solving for when we're solving the problem of making these chips that are mining our Bitcoin?
I'll start with this one. I'd assume Satoshi Nakamoto started mining in his basement, right? It was either an office or a room. So we started out with CPUs on a regular laptop. And then we moved on once the difficulty of the network rose and hash rate increased. We went to GPUs. Then we went briefly to FPGAs. And then there was new technology, right? The ASIC chips and the idea of using it for Bitcoin mining. Jumping from specifically GPUs to ASICs, I won't comment on FPGAs, but making that jump is massive. And the fear was that we would have 1 or 2 individuals who would take over the Bitcoin network, fork it, and all kinds of things could happen. Because once you have that, I mean, this is the Canaan, the Avalon Nano 3, right? So this miner could have took over the Bitcoin network back in those days. I could take it over with this in my hand. So when that technology was around, we were looking at it, we said, we have to save Bitcoin. So we decided to take that ASIC chip technology, invent the Avalon 1, the A1, and instead of mining ourselves, we sorted out the clients and we shipped to each one at in a kind of a way that spread out hash rate. So you could say we kind of saved Bitcoin back then. So we were that was what we did there. But specifically about solving the issue, so we use SHA-256. It's an algorithm that you could technically do on a piece of paper if you had a long time to do it. So if you ever tried Bitcoin mining on paper, you should try that. We take that technology with the Bitcoin blockchain and we use it to mine, right? And this can be done anywhere if you have access to the right technology, if you have the right ASIC chips. And I think we're going to talk about that, right? So,
Yeah. Can you take us into that? Because Avalon obviously has an important history, but I'm curious, what is the problem that we're solving for? Is it, how do I even go about solving this in these early days of an ASIC? Maybe there's a hardware conversation to be had, or maybe, Bob, you have some commentary, because you lived through an interesting time through the rise of personal computers. So, yeah, I'd love to get a sense of the engineering, kind of how we're solving this problem.
Sure. Yeah, I didn't say it in my introduction, but my past was primarily in the personal computer industry. I started in the mid-'80s designing personal computers. Ultimately was the chief technical officer at Gateway. And I think I designed my first ASIC, or was part of a team that did my first ASIC in '88. So one thing to be clear about is ASICs way predate Bitcoin. Bitcoin did not create the ASIC, and I'm glad you started out, by the way, of saying that we're talking about ASIC, the chip. Please do not call the server or rig or whatever it is you want to call it an ASIC. Okay, and I won't bore you with the reason right now, but it's very important, at least to me. We need precision in our language, and this is a technical group too. You should care about precision in your language. Okay, you've got your scolding for there. So, so is this mic okay? I hear for me it's kind of cutting in and out. If you want to do a really simple ASIC, control the headlights of your car or something like that, it's a pretty inexpensive process. I haven't done one in quite a while, but probably for a few $1,000s, you can get the basics done. I'll talk more about our project in a bit, but endeavoring to be at the leading edge of what we're doing now costs tens of millions of dollars. And that's part of because in our industry, there really is no market for an ASIC that isn't at the bleeding edge. And, right now that's 3 nanometer. It will be 2 nanometer not too long from now. And to everything from the PDKs to design the ASIC to, buying wafer starts and all those sort of things. It's a really big endeavor. And that's a big obstacle. That's a really big obstacle to creating diversity in this market. So I'm not sure. Does that answer the question?
Yeah, I'll keep it going. So I'd assume this crowd knows what ASIC chip is, but just for fun, it's a chip that does one thing really well, right? Whereas you have in a laptop a CPU, it can run a Word document or it can browse the web. An ASIC chip just does one thing; it repeats it over and over. So it's really it's really good for doing SHA-256 over and over again and getting those hashes out, right? So it's an application
specific
integrated circuit. And we use that now just to process the Bitcoin. And so I won't say ASICs anymore. I'll call it an ASIC miner,
Thank
right?
you. That's okay.
Yeah. But we do in this industry refer to them as ASICs, right? But the Bitcoin ASIC machines, it changed the way we're mining Bitcoin.
Yeah, I'd love to get thoughts from Zubair, because you are working on this with Proto. Could you tell us a little bit about just what does that look like? Because you're not attacking this from 20 years of old. You're working hard to be on that bleeding edge. So what does that look like from you?
So I've done ASICs, FPGAs, CPUs, GPUs. Oddly enough, I actually think doing this very specific. Let me back up for a second, because we asked what problem are we solving, right? The problem we're solving is basically we need a fast calculator. That's essentially what it is, a really, really fast calculator. So imagine if you wanted to use a calculator. You could pull out your phone or your laptop and do a calculation. That was what it was like with CPUs, right? Now let's say, okay, well, I don't need a CPU to do a whole calculation. GPUs have tons and tons of what they call compute units, which are all made up of arithmetic and logic units, right? So they have some of them have thousands of them. So it's basically, I have a crap ton of calculators now. But do I need that crap ton of calculators? Do I need all the overhead, because the GPU's job is to render frames for the display, and that requires calculation, but it's not just to do calculation. So that's when we move to the ASIC. The GPU, so this is how I say it. The CPU is like using your phone as a calculator. The GPU was like a TI-89. Anybody use the TI-89? Yeah, the TI-89. But what does the TI-89 do? It does a lot too. It does graphing, it does all this fancy stuff, right? But now what we want is, as fast as possible, a very, very specific calculator that does the SHA-256. Now we want to design a chip that only does that, because the demand for hash increases, the efficiency needs improvement, so we move away from all the overhead of a GPU and CPU just to give us that little calculator, in essence. That's the problem we're trying to solve, is we need the fastest calculator that takes up the least amount of energy.
Doing that one thing. Bob, were you going to add something to that?
Not really, but you know, I think that we're at a time where I'm going to shift a little bit, if that's okay. I think we're at a time where we have to mature as an industry, and part of that is, you know, to date, the people making the chips have been the same people making the systems, and I say this with respect, Christopher, to you and your company, but I think we're at a point where we have to have alternatives, where we just have at least some of the companies that just build the chips. So if we look back at my past, when I was at Gateway, if I was designing a PC based around the Intel Pentium processor, as an example, I had a relationship with Intel. I got a data book, which was like a 500-page book that told me everything about that chip. When I bought the chip, and we were obviously buying in large volume, we had an agreement that, you know, we would be notified of any change. We got engineering change orders on everything that went on with that chip if there was a revision. We had great technical support for it. And, you know, one of the things that strikes me about being in this room and seeing some of the work that many of you have contributed to is it's phenomenal work given the tools that you had. And I can't imagine how much energy you guys have spent trying to reverse engineer, recycle, and then I think about all the innovation that would have come if you hadn't had to do that. And I think for us as an industry to mature, we have to reach this point. It doesn't mean that companies like Christopher's can't continue to design their own ASIC and use their own ASIC, but there has to be an alternative. There has to be an Intel, AMG, Harris, TI type companies that you can go buy these ASICs from. And by the way, those ASICs will come in different flavors. Ones that have very low hash rate and very low voltages, and ones that have massive die sizes, and there'll be all ranges that you can buy them from. If we don't do that, I think we will greatly inhibit our growth. And by the way, we're not going to decentralize this network. And so some of you may or may not care about that. I'm very passionate about it. Not here to just shit on Bitmain completely, but like, we have to break that stranglehold. And I think this is one of the ways for that to happen.
So here's a round of applause for decentralization. You're reading my mind, Bob. This is exactly where I was hoping that we would go, is because we're looking around at these incredible innovations, and you know what Bob is expressing, every single one of you has experienced. But does anybody here work with bit axes? So if you have a bit axe, or you've used a bit axe that was probably desoldered from an existing machine, it's a pretty inefficient way to build things. And we're looking at these beautiful innovations that we have sitting in this back room, one of which is a heating unit that has 4 Watts miners, but they're still recognizably Watts miners. And you think, how much time could we have saved if I could have just gotten boards or the chipsets or chosen my own PSU? So I'm curious from you guys, what has to happen to get us there? What has to happen to break this kind of Bitmain chokehold?
Okay, so we have a diversification strategy for acquiring ASIC chips. So we have accounts at the biggest foundries in the world, And the top foundries, you can imagine there's Samsung, there's TSMC, there's a lot of different companies who do that. But the big ones, we have accounts there. And we design ASICs and then we put in our orders. It's a very expensive business. I mean, we're talking about multi-million dollar contracts to get these, right? And I just want to take one step back to where we talked about the problem. What problem are we solving, right? We're solving a problem of keeping Bitcoin decentralized away from individual actors with enough hash rate to fork the network. I'm not going to mention any companies specifically, but there have been attempts to do that in the past when hash rate was acquired. There were large loads, and then they wanted to fork off it to different coins, right? So what we're doing with more and more power in the hands of individual miners through these better and better ASIC chips is putting the hash rate of Bitcoin, more centrally placed on the globe. And this is exactly what we did in 2013. We wanted to make sure that not just one individual client had all that hash rate. Yes, we designed ASICs, but I would say that it's already very decentralized. The allocation or the procurement of ASIC chips globally, because we have two big foundries in two different places in the world. They're developing here in the United States again. So I think in time it'll be something that no one will have to worry about, and I don't think we even have to worry about it now. With Canaan, I think it's a company to look at because of our diversification strategy. We get our chips from all the major foundries, and that makes us a good option where some of our competitors just load in all of their capital into one foundry, and that's just where they get everything, where we're using the chips that we believe are best for Bitcoin mining. Heat resistance, hardy. Maybe they're not sometimes the fastest, but they're going to run 24 hours a day and not turn off at 1 p.m., 2 p.m., 3 p.m., 4 p.m. when the sun is the hottest and your data center is hitting its highest points. And then going to home mining, so we talked about other companies that do it. We have direct sources to get these chips and to put out products that can be put into home mining equipment. For example, like the Nano I mentioned earlier. We also have another miner coming out, the Mini, which is 800 watts. This one is 140 watts, and they run in the 20 joules range, 21 and 23 joules. So come on, that's awesome. We're talking about other products. We're talking about reusing miners that are old and taking the chips out. This is not how we expand the hash rate in home mining. We need products that are the top of the line ASIC chips, the same ones we use in our industrial miners, going into home miners. So that's what we're doing to do our part, because it's always been about protecting Bitcoin from the beginning. That's what we're doing. And that's the problem. We're trying to save Bitcoin. It's the first hard digital asset in human history. It's better than gold. We had 5,000 years of gold. Now let's have 5,000 years of Bitcoin, right?
Beautiful. Now, Zubair, you have something interesting. If people look up there, it says Proto MDK. And while I'm hearing you break down, you're taking me through the products, and I'm thinking, wow, you've really got a diversified set of products. You've got different applications. I'm noting that, okay, it's the miner development kit. So I wonder how you think about this. Do you think in terms of products? Do you think in terms of components, subcomponents? How do you want to address this through your business?
So I think it's a great question. And if you think about Block, right, the company itself, they started off as Square. We've all used a Square reader before, card reader. And if you think about the time before Square, how does a merchant, a one-person store, accept payment from a credit card? It was quite complicated. It wasn't easy. You couldn't invest. You couldn't get a card reader. And Square solved that problem. And that's essentially Block's philosophy, is to empower the population, empowering through financial means with the Square reader, and now to empower the Bitcoin mining population that in our entire ecosystem with chips and with rigs. So we are committed to release chips and rigs this year, and we want to make our chips available for everybody.
That's huge, huge. And are those chips coming attached to an S21? Do I have to desolder it?
So here's the thing. I come from a different background, right? When I see what you guys do, I am amazed, because if we had to do that, any company I worked for, we would have just thrown everybody out the window. There's no way we'd have taken on a project to desolder a chip and then put it into a production product again. Doesn't happen. All this hacking that they have to do with the firmware doesn't happen. And I'm extremely glad that Tyler invited me here because I can firsthand see all those problems and solve them. Because that's what I want to do. My career for the last 10 years has been enabling ecosystems, enabling customers, and that's what Block is about also, is to enable everyone who wants a Bitcoin mining ASIC or a rig. You'll all be enabled. And we've already began that with a mining development kit based on Intel silicon, and we've given 256,000 chips, of those Intel chips to the 256 Foundation. And so they can do open source projects with them. And I'm hoping that control board that they have, this open source control board, is controlling those chips.
That's
so,
right.
Yeah.
So for some reference on what Zubair is talking about, the 256 Foundation out of Nashville, they are dedicated to essentially decentralizing kind of the mining box and making it open source. So they have a series of projects that they're funding. Amongst those, the Ember One board, which is a 100-watt open source hash board, an open source control board, open source firmware called Mujina, an open source block watcher, and I forget the last one. The one-click install Hydra Pool. Thank you, Schnetzel. So this is what we're talking about, is that, and those chips, as I understand, are not just coming attached to anything, they're actually coming with instructions.
Those are chips with tape and reel. Tape and reel chips available to you. You guys solder them on whatever you want to solder.
So if you have a project here and you want to have an application or you have something where you need the chips, the 256,000 of them are somewhere around Nashville, and you can apply through the 256 Foundation to get a tranche of 5,000, 10,000 of them.
Yeah, and I my hat's off. I really applaud that. I think that this is absolutely critical. I mentioned this before, but I think if you look back, we'll use the personal computer industry as an example. None of the personal computer companies ever tried to build CPUs or GPUs. A few of them in the early days, including my company, we did chipsets, but we quickly gave up that. We developed the CoreLogic chipsets. And the reason was that they're wildly different skill sets. You know, you can't, to focus your organization and consistently be at the top end of chip design and of system design is extremely difficult. I think the fact that it exists in our industry is in large part a reflection of the fact that we're really early and immature. The world is going to be best, in my opinion, when we separate these two things. So what Block is doing, I think, is absolutely critical. What we're going to try to do with M5 is what we're in the early stages of doing. I shouldn't say we're a year and I'll brief you guys on what we're doing in a second, but we're a year and a half into our project. And there are a couple others. And because if you look at the personal computer, what did it ultimately become? The personal computer sits inside all kinds of things that don't even look like personal computers, right? And I think what you guys are proving is that's where Bitcoin mining will ultimately be. One of the earlier gentlemen came up talking about his thermal batteries, and you know it's difficult for the chip maker to have the vision of all the best ways to embody it. By the way, I love like this device that Christopher's company's doing. I think it's wonderful, but there's a bazillion of these ideas, and if we don't open up the chip making, the chip availability to everybody, we're just going to stunt that. And I'm sure a lot of you, we're pretty hardcore Bitcoin group here, have read the early writings of Satoshi, and you know he talks about millions of people using it for heat, right? And I think that's the only way we actually achieve decentralization. At the same time that new chips are being developed that will push enterprise level mining operations, we need something to offset that on the other side, because that's a massive centralizing force. I'm sure you all see it. The bigger miners are getting bigger. The pools are getting more centralized. I will maybe disagree with Christopher a little bit. I think that, I do worry a little bit about the silicon being central, the wafer production being centralized, but hopefully something will change there.
Yeah, so definitely, Christopher mentioned there's a few companies that make these chips at the process node that we need them at. And I'll trust me, I've been their customer for many different types of products. And since COVID times, the wafer shortages and the wafer costs have really changed. It's now becoming much more competitive to get capacity in a fab, to get space in a fab, to get a wafer at a price. I remember working on a chip, not at Block, but at another company during COVID, and we had to update the wafer price every month. That's how often it would change. That's how much the supply chain was in risk at the time. And now those, usually when costs go up, they don't really come back down, right? So the wafer cost is still very high. And as you go to these lower and lower process nodes, guess what? It's harder to make that wafer too. So the wafer will be more expensive. The yields get lower. Bob, you probably remember back in your time, you could get 90% yield on the first wafer. It's 30% now. You get 30% yield on the first wafer, if you're lucky. I worked on a product, 20 nanometers. We did the first wafer, we got one chip. Yeah, we should have gotten 200, 300 chips. We got one chip. So it's getting harder and harder to make these chips. And it's not like we were making them before where we could just keep shrinking our transistors. It's getting a lot tougher to do it. We have to come up with creative ways of now redesigning the transistor. Even these terms that we use, 2 nanometer, 3 nanometer, 5, Bob, you guys know, they're marketing terms. They can't shrink it anymore. They're doing other tricks, very interesting, and we call them tricks, but they're doing very interesting tricks to get you the performance of the next node without having to shrink the actual transistor.
Could we hit on that a little bit? Because this is something that I think for a lot of us very quickly becomes just the ether, right? This magic thing, it's the magic box. And can you help us understand what does an optimization look like? What is happening inside of this chip? Okay, it's marketing to go from 17 nanometer to 13 nanometer. I can kind of intuit that. But then as I kind of hit this, this decreasing improvement for each, decreasing improvements in marginal gains, what are we solving for? Am I just running into a physics problem that I'm trying to solve all day now?
Absolutely. So essentially, we're building switches, right? Sorry, I come up with these funny analogies to explain these things to my kids. So we're making, they ask, Daddy, what do you do? I say, I make billions of switches, right? So we're making millions and billions of switches. That's how we use a transistor. Now, we can make the throw of that switch smaller and smaller and smaller. That's what we've been doing by shrinking it. At some point, your switch will be so small that a little brush of air would kick it, would trigger it. And that's kind of the point that we hit with our transistor. That now, as we're getting below 16, below 10 nanometer, I believe FinFET came out around 10 nanometer, around that time. Now, that switch was so small that the electrons that get attracted into this channel, this current channel, could move into the channel before it was actually activated. So it's called electron migration. I'm sorry if I'm
Take us there. We love it.
over-explaining or under-explaining, right? So you've got this extremely difficult process of now you got to source silicon and these very expensive, high conductive materials, sometimes from mines that, are only one mine in Japan might have a material, for example, right? So it's not just the chip itself and the fab that is restricted in number of manufacturers, the raw materials are restricted as well, too. I worked on a chip many years ago. There was one mine in Japan, that metal was only from there. They had an earthquake, we were done. All production halted, right? So that's how challenging this business can be. At the same time, the science is extremely complicated. You're talking about, we take silicon, right? We take that raw material, then we have to dope it. We dope it with electrons or with, we call it holes, an atom without the electron. And then we layer it, silicon, metal, silicon oxide metal. We apply a voltage. That voltage attracts the electrons to create a current channel. Right? That's how, and that's the switch that we're using. So now we can't make the switch any smaller. By the way, then, when you're talking about nanometers, it's the geometry, the size of that current channel is what we call. We take that silicon, it comes in a wafer, which is basically a circle, right? It has indentions in it, so it looks like a waffle, and it looks like a wafer. Now it goes through these very complex stages of lithography, of various machinery that only one company makes, right? So I won't go through all the stages. I've had to go with the vendor through stage by stage by stage, day by day, and track what they're doing. And that's just the first. You get out of that, all that process, you have silicon, you have oxide, you have metal. You've basically applied those layers, right? Now you come out and you have a mask, and you come out of the fab. Now you're not done yet. Now you got to go cut out your die, right? Those pieces are die, and you send it to a manufacturer to put it in a package. So what we see as the chip is actually that's the package you see. You don't see the silicon inside.
So what I'm hearing is that it's becoming insanely competitive, not just the optimization of how you engineer the thing, but the way that you optimize your whole supply chain. I'm curious to get two additional trains of thought on the question of, okay, well, is it even feasible for us sitting here thinking about heat to ask for chips? Like, do you look at us and go, what are you, insane? Like, I just spent $50 million putting this together. I'm not just going to give you the chip. Is that the right question to ask? Are we going to be left out in the cold, so to speak, because we can't get the chips to power our heaters?
So the main idea is how to use Bitcoin mining in different ways, right? How can we use the heat that's produced by ASIC chips running? Let's take a step back. So I understand what you're saying about the transistors, and now that they're getting so small, we're worried about leaks and different. There's different. What I would say is Moore's law isn't dead. We're going to wild, crazy places. I've heard that the transistors they're smaller than actual lasers, and the light that's used to etch them onto the silicon. We're going to develop new technologies. It's going to keep going. There's even ways of transistors. They're talking about doing like oval shapes, and instead of having the points of the rectangular shape leaking. So there's all kinds of different advancements on the way, but. So not to go too deep into the woods with ASIC chips, if we look at the overall picture, what Bitcoin mining has traditionally been, it's a short industry, right? We've only been doing this since 2013 and then 2009 with the creation of Bitcoin. It's been you procure your miners, right? You mine the lowest possible operation cost, and you ROI, you get the return on investment of the miner, you make money until it's not profitable anymore, and then you get the next machine, right? The next update. And as we're getting to a point where the machines are becoming more expensive because they fluctuate in price with Bitcoin, right? They almost act like commodities, right? You have, for example, an ounce of gold, an ounce of silver, right? We have a per terahash for a Bitcoin mining machine. So we typically sell them as $10 per T, $20 per T, $30 per T. Well, the machines are getting expensive. It's becoming very industrial, and it's a tough business, right? So what we need to do is stay ahead and make sure we're staying profitable. We're keeping operation costs down, the cost of the miner procurement down, and the most power efficient machine possible. So let's segue into the heat side of it. What can we use how can we use the heat, right? Well, we're already doing that. There's greenhouses popping up in Canada, Greenland, in northern United States. There's a hot tub in the back where they're heating the water for Bitcoin mining. So the innovation's there, whether it's going to be using older chips from machines, or if you have a big account like we do, or Bitmain does, or MicroBT does from a foundry to acquire those chips, there's going to be different ways. And what I like about what Proto's doing with the kits is it can really develop the repair side and the after-sales side of the U.S. market. That's something that this side of the world's been a little bit slower on, but look at the group. I talked to everyone here, and everyone knows like every single part of the machine, how to repair it, how to solder, and what we need is that. Because Bitcoin mining, I don't know how many of you know about the Chinese Bitcoin mining back before it was banned, but they could repair 60 hash boards in a day, 10 miners a day, some, if they were, easy cases, 20. It was huge numbers. And the US, from what I've been seeing from mining here, is catching up. We're getting faster, we're getting better. So that's what I like about what Proto's doing. But if we want to talk about as a business, it's actually making money, or at least we're making money, we're getting Satoshis into our wallet, and we're also heating our rooms, we're going to have to find efficient ways to do that, because we're competing with miners at Walmart and Target that aren't very expensive, right? So we want to make sure that there's an incentive to the person using it. Hey, my Bitcoin private wallet, my wallet has a Bitcoin in it. This is so cool. I can give it to my son. I can give it to my daughter. I can give it to my uncle, or I can pass it on. At the same time, I was warming my house in the middle of December. So using the heat, we're already doing that, greenhouse, heating water, and the innovation will come. I want to just wrap up what I just said. Moore's Law isn't dead. We're going really cool places with semiconductor technology. And the heat, we're already thinking of the ideas, and they're there. We need to find lower costs to do it. And I think with such an expensive industry, that's something we need to focus on, because no one's going to buy a $5,000 miner that isn't making them any Bitcoin but can heat, the neighborhood or something, right? So let's be realistic, because typical Bitcoin mining traditionally has been all about ROI, return on investment. So we can use that, competitiveness and free market ideas to make it better.
Bob, you are somebody who has never shied away from innovating, and the one thing that I love about your vision in this space is that you knew who you were when you got here. You came with such a great set of experiences through your career that by the time you started mining Bitcoin, you already had a vision for what you would or would not do. So I'd love to kind of hear your ruminations on this, because you have a really strong sense. I don't know if anybody knows, but Bob is a horse. Based on the reaction, not many of you.
I'm a wild horse, yes.
I'd love if you could introduce us a little bit to how you think about this, because one thing I've loved about it is that you've always had it in the back of your mind, the vision and the kinds of things that you wanted to do in this industry.
Well, thank you. That's very kind of you. I appreciate it. And let me answer your question and then wrap a whole bunch.
Are you going to explain how you're a horse?
Okay. How I'm a horse, yeah. So I divide mining into 3 categories: elephants, horses, and rabbits, for those of you who haven't heard this before. Elephants are kind of the big mega sites, 50 megawatts, 100 megawatts, 200 megawatts. They're big and powerful like elephants. They're also immobile like elephants, and they're easy to hunt. And so I mentioned this to somebody earlier I was talking. I think we're living in a world where I think Bitcoin miners and the mining community itself is feeling kind of good about itself, and we look at things like the recent election as kind of a relief, and I guess it is in a certain way. But I'll also say that when you're complacent, you're at your most exposed. So anybody, if you look at any kind of security, when you're complacent, when you're comfortable, that's when you're most exposed. So be careful. We have to be careful about the decisions we make, because we could be sitting 4 years from now in a completely different environment. So I think the elephants, like I said, they're big and powerful. You can look at the hash rate and say it's helping secure the network, but I believe it's also an exposure. The rabbits sit at the other end of the spectrum. There's a lot of rabbits in this room today. They are small individual miners. Individually, they have very little power. but collectively they can do a lot of damage. Just like if you're a farmer and you got a big field of crops, one rabbit's not a problem. A whole bunch of rabbits are a problem. But the thing is, when you go start trying to shoot rabbits, they scatter, right? So having a tremendous number of rabbits in our infrastructure is very important. The horses are the small to medium size commercial mines. They might be 500 kilowatts, a megawatt, 2 megawatts. That's what my company specializes in. Especially important is if you can get a wild horse. So all miners are either wild or captive. They are captive if they're using permissioned energy, basically on grid. If you produce your own energy, you're wild, and that's the best kind of mining. So horses kind of sit in that middle ground between really big and really small. They have some power. They're very mobile. Some others in the room, maybe mine in the same size. If I see a threat, I can pack up and I can leave in usually a couple days from any of my sites. So anyway, that explains the horse thing. As it pertains to the topic here today, you asked the question earlier, which is, will you be able to buy chips? The answer is yes, you will be able to buy chips. Will you be able to buy the latest and greatest chips? Yes, you will. You'll be able to buy, I'm going to mix in. So my Project M5ers, which we talked about before, let me just back up a little on that. So I joined a project 18 months ago with a group of ex-Samsung, Intel, and Broadcom folks. It includes people that worked on the Intel 486, that created the solid-state disk division at Samsung. So these are people with deep chops in the silicon area. We looked at this opportunity of creating a company solely focused on designing chips and not on systems as, one, a fantastic business opportunity, and secondly, as a very important part of enabling the development and maturity of the Bitcoin ecosystem. Fortunately, even as a very small company, we have the relationships with companies like Samsung and TSMC that give us access to the latest technology that they're developing, and we can get allocation. To give you some insight into the things that we believe we can do and that others will also be able to do, first we'll talk about throughput. We think that algorithmically there's somewhere between 20 and 30% improvement that we can still get within the hashing algorithms themselves. So regardless of what process you're running on. We agree that Moore's Law is not dead, although as Zubair talked about, there's some gamesmanship going on. So when we talk about, let's say, 2 nanometer coming out a year or so from now, it's not exactly that. It's a kind of a weird, but you will see the efficiency improvements. So first you'll see the throughput improvements from that just linearly. But then you'll see in terms of power consumption, we should be this time next year seeing sub 10 joule per terahash chips available. So those of you who are out there designing can probably start thinking in those terms at the high end. I think you'll still see stuff produced in the 20 joules per terahash as well on some of the older processes. But I think that's kind of the range of chips that you'll see. And then I've talked about it semi-publicly, so I will consider this.
You're amongst friends here.
Yeah. So you'll also see some changes in that the pursuit of very large die sizes. Now, one of the things Zubair talked about is yields are really difficult, really, really difficult. And so if you can, building larger dies then is even harder. So part of the reason you see hundreds of chips inside a bit main instead of just a couple is that they're dealing with those yields. They want little tiny slices of the wafer instead of bigger pieces. But, we believe there are some techniques that will allow us to maybe push into the 10 terahash per chip range, at least for the top end of what's out there. So hopefully that gives you some insight, especially as you guys are out there thinking about the products that you're trying to develop and how to develop them. That'll give you some thoughts about what might be possible as you go into 2026.
Could we get a round of applause for our panelists? Thank you, gentlemen, so much. Now, what you have done here by announcing all the brilliant things that you're working on is that now as you look out on this crowd, you know exactly who is going to be trying to pin you to the wall to get an allocation of chips. So thank you so much for the time. We appreciate it. And thank you for sharing what's to come.
Thank you.
Thank you.
Yes.